everyone, welcome to my channel. In this video we shall learn trigonometric identities of chapter Introduction to Trigonometry, chapter number 8, class 10th. So these three are fundamental trigonometric identities. First one is sin²θ plus cos²θ is equal to 1. Second one is 1 plus tan²θ is equal to sec²θ. And third one is 1 plus cot²θ is equal to cosec²θ. Derive all these three identities by two methods. Let us begin with the first method, and let me take the first identity. The first identity here, sin²θ plus cos²θ is equal to 1. To solve this identity, you must know 6 trigonometric ratios. Which are the 6 trigonometric ratios? For that you have to remember one small trick called Pandit Badri Prasad Har Bole. So this is sin ratio, cos, tan, cosec, sec and cot. You have to use all these trigonometric ratios to derive all these identities. Let me begin with the first identity. First identity is sin²θ plus cos²θ is equal to 1. So for this sin²θ plus cos²θ is the left hand side part, LHS, and here RHS is 1. So you have to solve the LHS part to get the answer 1 of RHS. So you have to write the ratio of sin²θ. So what is the ratio of sin? P upon H. P upon H. And this is square, you have to write in whole square. Plus, what is the ratio of cos? B upon H. B upon H. And this is whole square. What is perpendicular for this given figure? So this is perpendicular, this is base, and this is the hypotenuse. So what is perpendicular here? AB. So AB divided by, what is the hypotenuse here? AC. And this is whole square. Plus, what is base here? BC. And hypotenuse is AC. And this is whole square. Next step, what you have to do? You have to write this AB square and AC square separately. So this is AB square and this is AC square. Same way here also BC square and this is AC square. Now we got the denominator same, therefore you have to write this AC square as it is at denominator place, and this numerator AB square and BC square you have to write as it is. So AB square plus BC square. So here denominator you can write as it is AC square, and numerator what you have to write? See here, AB square plus BC square. See the figure here. So AB is what? Perpendicular. So this is perpendicular and this is square, plus what is BC here? Base. So what is the Pythagoras property? Hypotenuse square is equal to base square plus perpendicular square. So here hypotenuse squares. Right? What is the hypotenuse? You have to write here AC. So AC square. So in place of this AB square plus BC square, you can write this hypotenuse as AC square. Now you can divide this AC square upon AC square is 1. Now we have proved this left hand side, so we got the answer 1, which was the required solutions. Therefore your LHS is equal to RHS. So what is the LHS here? sin²θ plus cos²θ is equal to 1. So this is the first identity I have derived here. Now let me derive the second identity, that is 1 plus tan²θ is equal to sec²θ. So here left hand side is this portion and this is the right hand side. So here also you have to write the ratio of tan 1 plus, what is the ratio of tan? See here, this is the tan, P upon B. Upon B, and this is whole square. So 1 plus, what is the perpendicular here? AB. What is the base? BC. And this you have to write in whole square. So 1 plus this AB square and BC square you have to write separately. So AB square divided by BC square. This 1 you can write by 1 upon 1. So here the denominator are different now. So if it is denominator different, then you have to do the cross multiplication. So if you cross multiply now, you will get the answer BC square into 1 is BC square, and 1 into AB square is plus AB square, and BC square into 1 is BC square. Now the denominator you have to write as it is, BC square. So what you will write here at numerator place, see for this figure. So BC square is, BC is here base, plus AB is perpendicular. So here also you can use Pythagoras property. What is Pythagoras property? Hypotenuse square is equal to base square plus perpendicular square. So what is the hypotenuse for this figure? AC square. So BC square plus AB square is equal to AC square. So therefore you can write here AC square. Now you can write this AC upon BC whole square is equal to, see here, AC is what here? Hypotenuse. Let me write here as H. And what is BC? BC is base, B, and this you can write as whole square. So this H upon B of which ratio? H upon B, sec. You have to write here sec square theta. So hence proved. So this is the required solution of this identity, sec square theta. So 1 plus tan square theta is equal to sec square theta. So this is the second identity you have to derive like this. Let me derive the third identity, that is 1 plus cot square theta is equal to cosec square theta. So this is the left hand side and right hand side is the cosec square theta. So let us solve this left hand side to get the right hand side cosec square theta. So here also you have to write the ratio of cot. So what is the ratio of cot here? B upon P. So 1 plus B upon P whole square. So what is base here? BC. So BC upon what is perpendicular? AB whole square. So 1 plus this BC square and AB square you can write separately. So BC square upon AB square. Now this 1 you can write 1 upon 1. Now here also denominator are different, therefore you have to do the cross multiplication. So 1 into AB square is AB square plus 1 into BC square is BC square divided by 1 into AB square is AB square. So this AB square you can write as it is, and see here AB square plus BC square. So this is AB is a perpendicular, so perpendicular square, plus BC is base square. And what is the Pythagoras property? Hypotenuse square is equal to base square plus perpendicular square. So what is the hypotenuse for this right angle triangle? AC square. So here AB square plus BC square is equal to AC square. So therefore you can write in place of this AB square plus BC square you can write AC square is equal to AC upon AB whole square. Now you see here, so AC belongs to hypotenuse, therefore you have to write here H, and AB is what? Perpendicular, H upon P whole square. So what is this H upon P of whose ratio? H upon P, cosec ratio it is. So therefore you have to write here cosec, and this theta you have to write here theta. So cosec square theta. This is the required solution of this identity, that is cosec square theta. So third identity is 1 plus cot square theta is equal to cosec square theta. This is how you can derive all these trigonometric identities by using all these trigonometric ratios. These identities you can write cos square theta is equal to 1 minus this sin square theta you have to bring to right hand side, sin square theta. And the second way you can write sin square theta is equal to 1 minus cos square theta. And this second identity you can write tan square theta is equal to sec square theta. So this plus 1 you can bring to right hand side, so that time you have to write minus 1, and then this 1 is equal to sec square theta. This plus tan square theta you have to bring to right hand side. That time you have to write here minus sign, and this is tan square theta. And this third identity you can write cot²θ is equal to cosec²θ. This plus 1 you have to bring to right hand side. That time you have to write here minus 1, and then this 1 is equal to cosec² theta minus cot²θ. Now let us derive all these three identities by second method. So for this you have to use the Pythagoras property. What is the Pythagoras property? Hypotenuse square is equal to base square plus perpendicular square. So this h square is 1. So 1 h square. So this base square plus p square you can write as it is, divided by this h square you can bring it to denominator place. So this is h square is equal to, this you can write b square upon h square, and this is the plus, and this you can write p square upon h square is equal to, so let me write this 1 here and here 1. So b upon h whole square plus p upon h whole square, 1 is equal to, so b upon h is ratio of, let me write as that small trick. What is that? Pandit Badri Prasad Har Bole, sin, cos, tan, cosec, sec and cot. So b upon h is whose ratio? B upon h. So this is ratio of cos. Therefore this is cos²θ plus p upon h is whose ratio? Sin ratio. Therefore this is sin²θ. So this is how you can prove the first identity, that is sin²θ plus cos²θ is equal to 1. So the same you got here, cos²θ plus sin²θ is equal to 1. Let us derive the second identity, that is 1 plus tan²θ is equal to sec²θ. So to derive the second identity you have to write the first identity as it is. So sin²θ plus cos²θ is equal to 1. This you have to write here as it is, sin²θ plus cos²θ is equal to 1. So what you have to do, you have to divide this by cos square both side. Divide both side by cos²θ. So this sin²θ plus cos²θ you have to write here as it is, sin²θ plus cos²θ, and you have to divide by cos²θ. Cos²θ is equal to, this side also you have to divide by cos²θ, 1 upon cos²θ. Now you can write this sin²θ upon cos²θ, sin²θ upon cos²θ plus this cos²θ divided by cos² theta is equal to 1 upon cos²θ. This sin²θ upon cos²θ is tan²θ plus cos²θ upon cos²θ is 1 is equal to 1 upon cos²θ is, so what is the reciprocal of cos sec? So therefore you can write this as sec²θ. So this is how you can derive the second identity, that is tan²θ plus 1 is equal to sec²θ. Now let us derive the third identity. So you have to use the first identity, that is sin²θ plus cos²θ is equal to 1. Now for second identity we have divided by cos²θ. For this you have to divide by the sin²θ. Divide both side by this sin²θ. So sin²θ plus cos²θ divided by sin²θ is equal to 1 upon sin square theta. So this sin square theta divided by sin square theta plus this cos square theta divided by sin square theta is equal to 1 upon sin square theta. So this sin square theta divided by sin square theta is 1 plus this cos square theta upon sin square theta is cot square theta. You can write cos square theta upon sin square theta, you can write cot square theta. So there is a relation between sin, cos and tan. So that's equal to 1 upon sin square theta. So what is the reciprocal of sin here? Cosec. Therefore you have to write here cosec square theta. So this is how you can derive these three trigonometry identities. So thank you for watching my video. Do like, comment, share and please do subscribe to my channel.